Okay, open up your Algebra Review notebook and let's go to the page about factoring. So we're taking this trinomial, and by trinomial I mean it has three terms. You can see the three pieces to it, and we're going to factor it down to be able to solve for x, because you can't solve an equation when there's x squared in it as is, like what you see on your screen. You've got to break it down a little bit. So I want you to think of it in terms of this. The first term, think of it as A. The second term, the middle one, is B. And the last one is C. We're going to use that to our advantage. So do you notice how nothing is in front of the x squared? So think of a 1 being there. We know if there's just an x that it represents 1. So A is 1, B is 11, and C is 24. Okay, so we're going to break this down. We're going to call it factoring by grouping. So over here to the side, I want you to make an x. The top little v of the x represents us multiplying A times C. And A was 1, C was 24, so that product would be 24. That's what would go there every time A times C. What goes in the bottom here is the B value, which is 11. So our goal here, and what we want to come up with right here, are a factor pair, so two numbers. When we multiply them, it gets to be 24. When we add them, it's 11. So let's just do some scratch work here. Let's think of factor pairs of 24. 2 and 12, 1 and 24, 3 and 8, 6 and 4. Okay? So they all multiply together 24, but it also has to add up to 11. Well, if I add those two, that gets me 14. That's out. If I add these two together, that's 25. That's out. 8 and 3, that's 11. There we go. So I know that I need a 3 here and an 8 here. That's how that works when you're thinking about your factor pairs. We'll talk about negatives in a little bit. So what we're going to do now that we have our two numbers, we're going to split the B into those two numbers. So watch what I do here. I bring down my A as is, but the 11x I'm splitting into 8 and 3 because 3 and 8 is still 11. So I'm going to rewrite it like this. Okay? Still the same value. I haven't changed the value. There's still 11 x's there. I just wrote them differently. So now what we're going to do is we're going to split that in half. So two terms on the left, two terms on the right. And now we're going to take out our GCF. GCF stands for greatest common factor. What's the biggest number I can take? How many x's can I take? So if I look here at x squared and 3x, there's not a number I can take out because one has a 1 and one has a 3. But they both have an x. So I can take an x from both sides, and let's see what that leaves me with. If I have x squared and I take an x out, that leaves me with an x. If I have 3 x's and I take an x out, that leaves me with a 3. Okay? I'm not subtracting an x, I'm dividing it basically. Okay? So it takes it out. Now let's do the same thing on the other side. What's the biggest number that goes into both 8 and 24? Well, that's an 8. Do both terms have an x? No. So 8 is my GCF. So now we're going to divide that out. What's 8x divided by 8 is x. 24 divided by 8 is 3. Notice what happened here. Those ended up being the same exact thing. That's what you want to happen. Don't just write it that way. Make it happen with a GCF. If your GCF is correct, then that will happen every single time. So to get our true factored answer, we're going to take our two GCFs, x and 8, group them together, and then we're going to bring down the one that repeats. We're only going to write it one time, and that is our final answer. Okay? That's all you have to do. Find those two magic numbers, split it up, and then work with your GCFs. Okay? Let's do another one. So we have our A, our B, and our C. And so we're working with some negatives here that we have to think about. So go ahead and make your X. What's A times C? 1 times negative 18, which is negative 18. Our b is negative 7. So we're thinking of factor pairs that multiply together to get negative 8 and add up to a negative 7. Well, if it multiplies to get to a negative number, that means one has to be positive, one has to be negative. So let's think about some factor pairs with 18. Well, I have a negative 6 and a positive 3. Does that get me to negative 7? No, that's negative 3. That's out. Well, let's switch it and see what happens. 6 and a negative 3. Does that give me negative 7? No, that's positive 3. That's out. Okay, another factor pair to think about. What about 9 and 2? What if we did a negative 9 and a positive 2? What does that give me? Negative 7. There we go. That's it. So we have a negative 9 and a positive 2. That will justify multiplying together to get negative 18, adding them together, and it gets me a negative 7. So let's take those two numbers now and split up our b and rewrite it this way. So x squared minus 9x plus 2x minus 18. Okay? So again, I just took the negative 7 and wrote it a different way. Now we're ready to split it down the middle and take out our GCF. So what goes into both of those terms underlined in green? There's not a number that goes there because it's a 1 and a 9, which there's not anything bigger than a 1, but they both do have an x. So let's take out an x and see what's left. X squared, take out an x, I'm left with x. Negative 9x, take out an x, I'm left with negative 9. And now let's do the same thing over here with the 2x and the negative 18. Is there a number that goes into both of those? Yes, a positive 2. So let's take out a positive 2. What are we left with? We're left with x, and the negative 18 divided by 2 gives me negative 9. That's exactly what we wanted. Again, that ended up being the same, which is perfect. So now let's take our GCFs, group them together. Take the one that repeated, bring it down, and there is your answer factored. Okay? If we were solving for x, we would go one more step, but we'll get into that a little bit later. Okay, now with the next one, notice we actually have an a value other than a 1. So let's talk about how it works with this. It's the same process as we did before. We have our a, our b, and our c. So let's make our x. We have a times c. So 2 times 5, which gives me 10. Our b is 11. So what's a factor pair of 10? So two numbers that multiply together to get 10 and add up to 11, which we can think about that really easy, which is 1 and 10. Okay, so let's rewrite this. 2x squared. And I'm going to put the 10 first because to me the 10 will go with the 2, but it also goes with the 5. So it's kind of your choice there. Okay. Split it in half. What's our GCF here? We can take a 2 out. But we can also take an x. We can divide a 2 from both and we can take an x from both. So now let's see what we're left with. If we have a 2x squared and we divide out a 2x, we're only left with x. If we have a 10x and we take out a 2x, we can divide 10 divided by 2, which gives me 5, and there's not an x left. Okay, let's do the same thing over here. You're thinking, what kind of GCF are we going to have? We don't have the same numbers, common numbers. We don't have x's in both terms. So if that's the case, then your GCF is just a 1, which makes it nice. If you're dividing by 1, will anything change? No. So we will just bring this down. And look what happened again. Those two match. Perfect. Bring our GCFs down. 2x plus 1. Our repeat, x plus 5. And we have it factored. It would work the same way if you had flipped the 10x and the x in the very beginning when we split up the 11. You would have gotten the same exact answer. All right, last one. Again, our A is something other than 1, and that's okay. It's the same process over and over. So here we go. A times C. A is 6, C is -5, so that would be -30. B is 7, so we're trying to think of a factor pair that multiplies together to get -30, but adds up to a +7. So let's just kind of throw out some factor pairs. 5 and 6 comes to mind first, but again, 30 is negative, so 1 has to be positive, 1 has to be negative. Well, that gets me a -1, that's out. If I switch it, that's a +1, that's out. What's another factor pair of 30? 10 and 3. So let's say 10 and -3, and there's my 7. So 10 and -3, and there's our two magic numbers. So let's split our 7 up. 6x squared plus 10x minus 3x minus 5. Okay? I would have probably switched those up just because I would like to group my 6 and 3 together and my 10 and 5 together. So let's go ahead and do that. If you get to that point and you're like, oh, that GCF is going to be kind of difficult, erase and switch it up. Okay, split in half. So what's the biggest number that I can take out of 6 and 3? That would be a 3. They both have x's, so I can take out an x. And let's see what's left. 6 divided by 3 is 2. I still have an x left because I started with x squared. -3x divided by 3x gives me -1. Okay, let's do the other side. What's the biggest number that'll go into 10 and 5? Which is 5. They both don't have x's, so 5 is my GCF there. 10x divided by 5 gives me 2x. -5 divided by 5 gives me -1. Happened again. We have a match. So let's group our GCFs together and bring down the one that repeats. And there is factoring. So the biggest thing to think about is make your x, figure out your factor pair, split up your B, and take out your GCFs. If you need help with GCFs, let me